Hey everybody, so now we're gonna do IGCSE 0620/22 May June 2020 paper, and we're gonna finish this stuff off. We're gonna annihilate this and we're gonna solve all the questions. Okay, so without further ado, let us just move into the past paper. So now, question 1 says a mixture of ice and water is left to stand and the ice melts. Okay, and it says which row describes what's happening at as the ice is melting. So it wants you to describe what is happening when the ice is melting, and you've been given temperature of the mixture and energy changes. Now you guys remember, in melting there is no temperature change. The temperature stays the same, stays constant, and the reason for that was because the energy was not used to increase the kinetic energy. The energy from heating, the thermal energy that was being provided was actually being used to break the bonds or overcome the forces of attraction. So that is why the temperature was constant, and we realized that through our beautiful heat curve. So wherever the temperature was constant, I was saying that melting, boiling, or whatever was shown in the whatever temperature was shown in the heat curve, that was taking place. So we realized that the temperature should be constant. So B and A are wrong, and the energy, and the reason for that is that the energy is used to overcome the forces of attraction. So D is my answer. Part 2 says which apparatus is used to measure 25 centimeter cube of aqueous sodium hydroxide. Now 25 centimeter cube, we realize that a pipette is the best option for that, and we circle D. But I tell you, a beaker can also do that, but it's the pipette is more precise, and you do that to measure sodium hydroxide for titration purposes. Remember, you used to do that in titration. So we've done this stuff. Dropper is not used and conical flask is not used. We mostly used for mixing stuff, right? So D is our answer. Now part 3 says paper chromatography is used to determine RF values of 4 different food colorings. RF value, which food coloring has an RF value of 0.6? Now we have to calculate the RF value, the retardation factor value, and what was that? How do we calculate that? It's the ratio of the distance covered by the component to the distance covered by the it's the distance covered by the component, ratio of the distance covered by the component to the distance covered by the solvent front. And that distance is 25 centimeter. And because here it's centimeter, right? And now we have to calculate the ratios. So let's do it. So A is 10 divided by 25. B is 20 divided by 25. C is what? 15 divided by 25. D is 5 divided by 25, and you calculate all this good stuff. So let's do this. 10 divided, I reckon C is our answer, but let's see. 10 divided by 25 is 0.4. It asks for 0.6, so A is not the answer. B is 20 divided by 25. It gives us 0.8. We need 0.6. So B is also not our answer. C is 15 divided by 25. That is 0.6. And my guess was right. C is our answer. If you look at D, D is actually 0.2. Right? So C is our answer because it wanted what? It wanted 0.6 RF value. Right? Now, part 4 says the diagram shows the electronic structure of a particle with a nucleon number or the mass number that is 40. So it should have a nucleon number of 40, right? The table shows the electronic configuration of 3 particles, and it shows the suggestions of 3 students, 1, 2, 3, made to identify the particle. Okay, so student 1 says that the particle is argon, student 2 says that the particle is chlorine, and student 3 says the particle is calcium 2 plus. Now it says which student is correct. Now what you realize is calcium 2 plus, how many nucleons does it have? If you look at your periodic table, I already know that good stuff. It's 40. 40 is the nucleon number of calcium 2 plus, and argon has also a nucleon number of 40, and chlorine has a nucleon number of 35.5, or the mass number of 35.5. So chlorine is wrong. Argon is absolutely correct because it has a complete octet. If you look at the electronic structure drawn below, it's 2, 2, 2, 2. So you have 8 electrons in the outermost shell, and you realize that is argon. But what you also realize is when you have calcium 2 plus, you realize that it loses 2 electrons. And why does it lose 2 electrons? It loses 2 electrons to have a stable electronic configuration. So that's also 8 electrons in the octet, and if you can draw this out as well. So you have 1 and 3 as your correct option, therefore B is the right answer. Now part 5 says P and Q combine together to form a compound. What type of bonding it is? So if you see, Q is like literally it has an outer electron or a valence electron of 1. So it has one valence electron, which means it's in group 1. And P has valence electron of 2, 4, 6, 7. So it literally has 7 valence electrons, which actually means that it's going to be a part of group 7. And what you can do is you can literally say, okay, group 1 is a metal and group 2 is a non-metal, and therefore there is a transfer of electrons. So I'll say non-metal, and there should be a transfer of electrons from metal to non-metal, so it's an ionic bonding. And now it wants the formula. So formula, you realize that Q is gonna be, let's take, if you don't understand this, take a metal from group 1. So let's say I'm taking lithium, and take a non-metal from group 7. Let's say I'm taking chlorine. So lithium has a plus charge, chlorine has a minus charge. You cross multiply this good stuff, you get LiCl. And what was Li? Li was Q with me, and Cl was P. Now what they've done is, that's actually wrong the way they've written it. The formula should have been QP, but they wanted to confuse you even more, so therefore PQ is the answer. So A is my beautiful answer. Okay. Now it says, which statement about the structure of the metal explains why metals are malleable? We realized that malleability was what? When layers of metal slid over each other because they were very, very regularly arranged. Okay, and malleability meant that you could cut them and you bend them and hammer them into other shapes and structures, right? So the layers of metals should slide over each other. So if I look at my options here, the electrons can move freely through the lattice. That doesn't mean that it should be malleable. It does, but it doesn't, like, the electrons do move freely through the lattice, but that doesn't explain why the metals are malleable. Malleability only depended on, because the metals had such a regular structure that the layers could slide over each other. That's why we were moving on into alloys, because malleability meant that metals were actually soft and we wanted hard compounds. That's why we add an alloy here, right? So if I look at my options, part B says the layers of metal ions can slide over each other, and that's the right answer. Okay, and we can eliminate C and D. The bonding structure and metal point of sodium chloride and sodium dichloride, sulfur dichloride are shown. Why does sulfur dichloride have a lower melting point than sodium chloride? Because sodium chloride is what? It has ionic bonding in it. It has ionic bonds. It's an ionic compound, right? But sulfur dichloride, what you realize, it's a simple covalent molecule, and what you realize is that it has weak van der Waals forces, or weak forces of attraction. Yeah, so weak van der Waals forces. Simple molecules. Why do simple molecules have lower melting point? The reason for that was, between molecules they had weak intermolecular forces of attraction. Yeah, weak attractive forces between the sulfur dichloride molecules. So I can either say weak van der Waals forces, or weak attractive forces, or weak intermolecular forces. That's the same thing. So if I look at my options, the covalent bonds in sulfur dichloride are weaker. No, the covalent bonds are stronger. They are not weaker. What are weaker are the van der Waals forces, the forces of attraction between the sulfur dichloride molecules. Okay, and then it says the covalent bonds in sulfur dichloride are weaker. Again, they are very, very strong. The attractive forces, yes, the van der Waals forces, or the attractive forces between the molecules in sulfur dichloride, are weaker than the attractive forces. No, 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 no. You realize that sodium chloride के अंदर you have the same van der Waals. The same van der Waals will be here, as there will be the same van der Waals will be in sulfur dichloride and in sodium chloride. That's not the reason. Sodium chloride is strong because it will have ionic bonds. Okay, so the attractive forces between the molecules in sulfur dichloride, yes sir, are weaker obviously than the ionic bonds between sodium chloride. And that's my answer, because we are talking about why essentially you have a greater melting point. Yeah, so that's actually D is my answer. Now lead nitrate reacts with potassium iodide to form a yellow precipitate, and it says which equation for the reaction is, so it just wants you to balance out the reaction and balance out the equation. So lead nitrate lead nitrate plus Ki, and it even tells you what it makes. It makes a yellow precipitate lead iodide, and it makes a soluble salt KNO3. Now, I can literally do this so easily by saying, is here you have I2, here you have a single I, so I have to multiply this with 2. And if you see A is your wrong answer, because A does not have a 2 here. I just wrote that 2, okay? So A is wrong. And then what you realize is you have two nitrates here and you have one nitrate here. So you multiply this with 2 as well. Therefore, B is wrong as well, because B does not have a 2 right here. Okay. So between C and D, what you realize is which one will be my answer. Let's see. In C, they have written lead is 1 here, and you have two lead molecules here. What you realize is that is wrong, because lead is not balanced now, and even the nitrate is not balanced. So what you realize is that the only possible answer is D, and you can beautifully check out every stuff. But what I tell you guys is I'm solving the MCQs through your perspective. I already know how to balance and how to do all the stuff, but I want you guys to think how to think in the paper. I'm giving you guys the thought process of it, okay? So you guys are not confused on a single MCQ. Then it says the Haber process is developed. The reaction has 30% yield for ammonia. Which volume of ammonia gas measured at room temperature and pressure is obtained when reacting 0.75 moles of hydrogen with excess nitrogen? Okay, so it's saying you have 0.75 moles of hydrogen, and it wants you to calculate the um it wants to calculate the volume of ammonia gas. So how do you calculate this? You realize that I have to go to ammonia gas and I have to use my stoichiometric equation to cancel out the units until I reach my desired unit. So 3 moles, we realize that 3 moles of hydrogen gives me 2 moles of ammonia. And I realized then through using my mole relationship that 1 mole of ammonia will always give you 24,000 centimeter cube of volume, because the answer is in centimeter cube, so I want it to go directly into centimeter cube, right? And if I calculate this, so 0.75 times 2 times 24,000 divided by 3, you literally get 12,000. Okay, so I'm getting 12,000 centimeter. But before you do C, what you realize is that C cannot be your answer, because it says the reaction has a 30% yield of ammonia, which actually means that whichever volume you calculate theoretically, the efficiency of the reaction is 30%. So you will always get 30% of that stuff, of the theoretical value that you have calculated. It's a pretty poor factory that they're working in, right? So I have to calculate 30% of that. So 30% of 12,000 will literally be equal to, so into 30%, I realize that it's 3,600 centimeter cube, right? Therefore, A is my answer. Okay. Then it says which rows are correct for each electrolyte. So let's do this. Aqueous sodium chloride has Na plus, Cl minus, it has H plus and OH minus. And what urea cathode is the negative terminal, positive, the panic. So positive is anode, negative is cathode, right? And your anode is the positive terminal. And what you realize is what is happening at the cathode, at the negative terminal, you realize that always hydrogen will go and discharge, because it's more faster and quicker than Na plus. And at the positive terminal, what you guys realize, since it's dilute, so the hydroxide ion will discharge. Therefore, you will get oxygen, because 4OH minus gives you 2 water molecules, O2, and 4 electrons. Okay, so you realize that oxygen is formed at the anode, therefore 1 is correct. Then it says concentrated hydrochloric acid. Let's do that. So you have H plus and Cl minus and OH minus ions, because it's concentrated, and since it's an acid, it's always it's aqueous, so it'll have the hydroxide ions as well. But what you realize, what will happen at the cathode? Obviously the hydrogen will discharge, and that's the right equation for that. And then at the cathode, sorry, and then at the anode, because it's concentrated, you realize that the chloride ion will discharge, and therefore chlorine will be formed. So 2 is also correct, and since 1 and 2 both are correct, I can simply circle A without looking at 3 and 4, because that doesn't make sense for me. I know 1 and 2 are correct, or options may you only have two options there, yeah. But even if I look at 3 and 4, you realize that molten sodium aluminum oxide may you have Al3 plus and O2 minus, and what you realize is that aluminum should be formed at the cathode, not the anode, because cathode is negative terminal and it'll attract the positive ion towards it. But here they've shown that oxygen, so they've actually reversed this stuff for you guys. So 3 is wrong. And concentrated aqueous sodium bromide, where bromine will be formed, but here hydrogen should be formed. So 4 is also wrong. Okay. Now it's saying the electrolysis of copper separated using inert electrodes is shown. Which statement about the reaction about a reaction at the electrode is correct? So it's, the positive terminal is your anode, the negative terminal is your cathode, and you have copper 2 plus and SO4 2 minus. But since it's aqueous, you realize that you also have H plus ions and OH minus ions as well. And it's saying which is correct. And so what you realize is that copper 2 plus has a greater tendency to discharge than H plus because it's more reactive, you realize. And we've done all of this stuff because the iron will be more reactive than the metal that was before, okay, in the reactivity series. So you have, please stop calling me a careless zebra, instead try learning how copper saves gold, right? And you realize that Cu2 plus will be greater in will have a greater discharge than H plus, and Ag plus will have a greater discharge than the both of those, and then Au plus will have a greater discharge, or Au2 plus will have a greater discharge than all of them, right? But in आपके course में you only have till copper 2 plus, right? So copper ions will gain electrons at the negative electrode. That's absolutely true. It won't gain electrons at the positive electrode, and hydrogen ions can't go because you have copper 2 plus which will discharge. Okay. And then question 12 says methane burns in excess oxygen. The equation is shown, bond energies are shown. What is the energy change for the reaction? So how do you calculate the energy change, the enthalpy change? It's the bonds broken minus the bonds formed. And what are the bonds broken? So you have methane, so it's CH4. Okay, so you have CH4 and you realize that you have to break all these bonds. So let's break CH4 bonds. So I have to break this CH bond, this CH bond, this CH bond, and this CH bond. So I have to break 4 CH bonds. And what's the bond energy for one CH bond? It's 410. So 4 times 410. Okay, and then I have O2. So I know that you have O double bond O in O2, and I have to break one O2 double bond. Since you have two molecules, you realize that you have to multiply it with 2. Okay, and what you see is 2 times what is O2. O2 is 496 is the bond energy for O2, so 496. So 2 times 496, and what you realize is I don't even have to do more. It's 4 times 410 plus 2 times 496, and the other options do not have all of this stuff. So B, C, and D does not have this stuff. So A is my answer. You can literally just stop here. But if you want to find the bonds formed, you can also do that. So minus, what will be the bonds formed? The bonds formed are carbon dioxide. So carbon dioxide is C double bond O, and C double bond O is 805. So you say, okay, it's 2 times 805, and then you say, okay, plus water is O bonded to an H, and then O bonded to an H. So you have to break this bond and this bond. So I can literally say that it's gonna be 2 times, this 2 is already there, but since I have to break 2 bonds, so I multiply this with 2 again, and one OH bond is how much? One OH bond is literally 460. So you can say 2 times 2 times 460. So it's actually 4 times 460, and then the entire equation is proved right here in part A. Okay. Which statements about hydrogen fuel cells are correct? So water is formed as the only waste product. That's true. That's why we use hydrogen fuel cells. Both water and carbon dioxide are formed as waste product. No, carbon dioxide is not formed. If it was formed, then why do we use fuel cells, guys? Why are we stressing over fuel cells? The overall reaction is H2 plus O2 as give you 2H2O. Yes, sir. That's correct. And the overall reaction is endothermic. No, it's not going to be endothermic. The reason for that is, then why are you using fuel cells? If it was endothermic, you remember I used to tell you guys that combustion. What is combustion? When combustion was occurring, आपकी गाड़ी जा रही थी, right? The car was not moving because of carbon dioxide and water. The car was moving because of the energy provided due to combustion. So there's this energy that is provided by the hydrogen fuel cells, and so you realize that there's a release of energy. So it's not endothermic, it's exothermic. So 1 and 3, A is the correct option. Okay, then it says which list contains only chemical changes, so we have to only do chemical. Melting is a physical change, I realize A is wrong. Rusting is a chemical change. Freezing again is a physical change. Subliming is a physical change. The reason being is physical change. What you realize is I gave you guys a simple explanation that physical changes and chemical changes had one major difference. That was in physical change, you were using the same substance but changing it into different states. There was no new product being formed. In chemical changes, you literally have new products being formed. And I gave you guys the example of sodium and chlorine, that sodium is a metal, chlorine is a poisonous gas. And what you realize, when they combine together, you get NaCl, that's edible salt. So that's a new product, which means the chemical change has taken place. And in physical change, I gave you guys the example of melting, boiling, subliming, freezing. They were all physical changes because you're just changing the state. You weren't changing or making new products to it, right? So that's why B is wrong. Neutralization, yes sir, that's acid-base reaction. Polymerization, yes, you're making polymers from alkenes. Combustion, yes, you're making new products as carbon dioxide and water. So C is my answer. Again, boiling, condensing is not an a chemical change. So D is also not my answer. Distillation is also not a chemical change. Okay, so 14 made D, C was my answer. Now 15 says the result of adding excess marble chips to hydrochloric acid are shown at 50 degrees Celsius and 30. The only thing that's changed is temperature. Which row describes the reacting particles at 30 degrees Celsius compared to 50 degrees Celsius? So it wants you to tell them, okay, what were what was the rate of collision? So the collision rate and the collision energy at 30 degrees Celsius compared to 50 degrees Celsius. So what was that? It was lower. At 30 degrees Celsius, it was lower. The collision rate was lower because the collision energy was lower compared to 50 degrees Celsius, right? So you say D is your answer. So obviously the collision energy is lower and the collision rate both will be lower. Okay. 16 says method, sorry, it says methane reacts with steam and an equilibrium is reached. The forward reaction is endothermic. Okay, sir. Which row shows how the amount of hydrogen, the equilibrium is changed when the pressure is indicated? Okay, so it says कि amount of hydrogen को क्या बुलाओगे? What will happen to the amount of hydrogen if I change the pressure and if I change the temperature? And they've given you different options for that. So it's first of all, it says the forward is endothermic. So you write it's endo, and so the backward should be exothermic. Let me fix that for myself. Okay. So if they say there's a decrease in temperature, so what will happen to the amount of hydrogen? If there is a decrease in temperature, it'll favor the exothermic part and the hydrogen amount will decrease, not increase. So A is wrong. Then it says if I increase the temperature, the hydrogen amount, the equilibrium, if you increase the temperature, obviously it favors the endothermic part. So the hydrogen should increase. The amount of it will favor the right, the forward reaction, and the hydrogen amount should increase. Here it's written decrease. So B is wrong. And it says, Acha, now they're not messing with the temperature, now they're messing with the pressure. What you realize is high pressure favors, we know this, that high pressure favors less number of moles and low pressure favor more number of moles. Yeah, so let's do this. So increase in pressure actually means high pressure, it'll favor less number of moles of gas. So you have four moles of gas here and 2 moles of gas here. So if you increase the pressure, the hydrogen amount should decrease because it's going to favor the backward reaction, the reverse reaction. And that's true. The hydrogen amount will decrease. So C is my answer. But if it says you decrease the pressure, obviously if you decrease the pressure, it will favor more hydrogen being made. But here it's written that the amount of hydrogen should decrease, which is wrong. It should increase then. Okay. So C is my right answer. Now, it says when aqueous iron 3 chloride is added to potassium iodide, the chemical reaction occurs and iodine is formed. Which statement is correct? Now, guys, what you realize is even if you don't know the reaction, I'm going to write this reaction for you guys. So you have iron chloride plus potassium iodide, and it will form iron chloride twice, plus you will have KCl plus I2, iodine being formed. But even if you don't know this stuff, you realize that you had potassium iodide, you had Ki, and it is going into I2. What is happening? Ki was -1. The oxidation state here of I is -1, right? And it's going from -1 to 0. So what is actually happening? It's being oxidized. So it's being oxidized, it's losing electrons. So iodide ions are are oxidized because they lose electrons in this reaction, and B is my answer. They don't gain electrons by being oxidized. Okay, so you don't even have to literally look at C and D part, and C and D are obviously then wrong. Okay, then it says which letter represents, so you have acid, base, and salt and water. And it says which letter represents the area of the graph where both acid is present and the salt is present. So what you realize is the salt has been formed, and then it says that acid is also present. So think about this. It says that you have a pH solution and acid is being added to an alkali. So here you had in a beaker, you had an alkali, and you were slowly and gradually alkali's pH was almost 14 here, it's shown, right? And you were adding acid to it to neutralize this, so it was getting neutralized again and again and again and again. And what you realize is here you have approximately, I can say here a salt is formed, because what you realize is at D the pH is very, very low. At D the pH is low. It's almost like what, it's almost like, let me see, it's 2, okay, or 1, whichever you guys like. It's 2 or 1 at D. So what you realize is an acid is being present here, and acid is here because of the lower pH. And I also realized that above a salt was also formed. So salt plus acid is right here at part D, and I can see that because of the pH, right? It says which statement describes a weak acid? It should partially ionize when dissolved in water or in an aqueous solution, right? So partially ionize. Okay, let's do this. And weak base, so they're talking about proton acceptor, proton donor. You realize that a weak acid, an acid is always a proton donor, not an acceptor, right? So part A and B are obviously wrong, and so it is a proton donor that partially ionizes in aqueous solution. D is my right answer. That does not fully ionize, is a strong acid. Okay, then part 20 says the apparatus shown is used to prepare aqueous copper 2 sulfate. What are X and Y? So what I realize is we are actually preparing copper 2 sulfate, which is a soluble salt. And for a soluble salt of other than group ones, we were doing excess method. So what was our excess method? We used to take either the metal or the metal oxide. So we used to take metal or metal oxide, and we used to add acid to it, right? And we used to add this should have been limiting, and this should have been in excess, and we could actually remove. And the reason for that was we could remove metal or metal oxide through our filter funnel, because here you could just remove the chunk, the block that was left, right? So if you literally had a metal right here, you were adding acid to it, and this salt was being formed here, and then some of that metal was left because that was in excess. So let's say this was left, I could easily filter that metal out. Okay, so what you realize is it says what is X and what is Y. So what you realize is that Y should have been acid, because it can't be this sulfate and it can't be this aqueous 2 copper chloride. And what you also realize is, listen, if you're adding copper to iron sulfate, no reaction will take place, because iron is more reactive than copper. Copper wouldn't even be able to displace this iron 2 plus, right? So that's also a reason to cancel this stuff out. Now the only actual answer left is copper chloride and copper oxide. And what you realize is I either take metal or metal oxide, so I can literally say that C is my answer. But let's do C for a while, and let's do B. Why B is wrong? B is wrong because if you have copper chloride, first of all, that's a salt on its own. And what you realize is, agar to chalam, let's for all argument's sake, what if I add it into sulfuric acid? What you realize is H2SO4 mein, even if I add this stuff in H2SO4 and I say, oh, ye to ho jayega, kuch na kuch isse ban jayega, what you realize is, if copper sulfate is even formed, the other thing that will be formed is HCl, and that's going to be an aqueous state, and that's going to be an acid that's going to be formed here. And here the end product was copper 2 sulfate. It should have had the HCl acid as well, which is not written here. So you can literally say that B is wrong too. And actually copper chloride is a salt, and salt and acid, guys, come on, you're better than this. Okay, so C is my correct answer, because it's copper oxide, and you add it to dilute sulfuric acid, which is limiting, and then at the end what happens is the solid X So the excess of copper oxide is being here and it's filtered out, and then you literally have your beautiful copper sulfate. And copper oxide can react with sulfuric acid to give you copper sulfate. And what? Okay, which process is not used in the preparation of insoluble salt? So insoluble, obviously, that's the most important process. Filtration aap karte ho, then you wash that stuff off, and then you dry that stuff off. Crystallization is used in the preparation of a soluble salt, not an insoluble, because you have, for let's say, let's take the example of maybe copper sulfate, jo humne upar abhi kiya hai. So you have copper sulfate aqueous, you want to remove the water out of it, so you crystallize it, you heat this good stuff, so water is removed, and you get copper sulfate crystals. So that's used in soluble salt, not insoluble. Okay. Now it says which statement about group 1 and group 7 elements is correct? Group 7 elements are monatomic? No, they are diatomic. Gases, chlorine, bromine, iodine, they're all diatomic. Yeah, they consist of two atoms. Lithium is more reactive than cesium. No, cesium is more reactive because down the group the reactivity increases. And I've given you guys the reasoning for that good stuff. Okay. The melting points of group 1 metals increase down the group. No, they decrease because the metallic bonding becomes weaker down the group, because the metallic bonding depends on how strong the melting points depends on how strong the metallic bonding is. And since the volume is increasing of the atoms down the group, you realize that the metallic bonding is becoming weaker, because for the same amount of charge, the charge is being more spread. Okay, and I've given you guys reasons for that. So those of you who are getting confused, you better take my classes then. Okay. Potassium bromide. So the last option is D. I can literally just circle D without even seeing it. But let's see what D says. It says potassium bromide reacts with chlorine. Obviously, chlorine will displace this because the more reactive halogen will displace this good stuff, the less reactive one, the less reactive halide, and you will have KCl being formed and Br2. And Br2 is obviously, you can say it's an orange solution. Yeah. So it does produce an orange solution, D. Part 3 says the properties of element titanium can be predicted by its position in the periodic table. Which row identifies the properties of titanium? So it's actually a transition metal. I'll tell you, you guys can check it out. I know that it's a transition metal. Yeah. So it can be used as catalyst, obviously. So D is wrong. It conducts electricity when it's a solid. Obviously, it's a metal. So C is also wrong. Then it says it has a low density. Even if I can't comment on the density, I can literally say it forms colored compounds. Yes, because it's a transition metal, it will form colored compounds because of the variable oxidation states. Therefore, B is my answer. And we realize they have high density. Yeah. Which diagram shows a mixture of noble gases? This is literally a compound. That's actually diatomic molecules. This is actually, I don't even know, it's a mixture of gases here. D is a mixture of noble gas. Am I right? Is D actually the mixture of noble gas? No. It's not. Sorry, guys. My bad. D, what you realize is that D is not a mixture. It's just a single type of noble gas. Yeah, because you've given only one type of atoms here. Like one type of one type. They're all the same color. A is actually a mixture of noble gas. Sorry. I'm also solving this past paper right now with you guys. I've not solved it before. So I'm doing it right now with you guys. So I have to use my brains as well. Okay. A is a mixture because it has one. Let's say this is argon. So to differentiate it, they've used a different color. So maybe this is, helium. Let's say this is helium. Okay. But if I'm saying this is helium, then all of these are helium. It's not a mixture. It's just one type of. Read the question on. We have to have a mixture of noble gases, not just one type of noble gas. Okay. So A is my answer, not D, guys. Which property is shown by all metals? So all metals do conduct electricity. Yes, that's right. Not all metals are can be extracted by their ores from heating with carbon. You realize कि carbon से जो ज़्यादा, which are more reactive than carbon, they cannot be displaced or reduced by carbon. Okay, they form acidic oxides. No. Non-metals, mostly non-metals form acidic oxide. They form basic oxides, and they react with hydrochloric acid to form. What you realize is they do react, but copper does not react, silver does not react, gold does not react because they're less reactive than hydrogen, so they can't displace this stuff. Okay, now many metal carbonates decompose when they are heated. Which row describes what happens when potassium carbonate and this are heated with a Bunsen burner? Okay, so let's do this. Which one will decompose easily and which one, even if you don't know this, look, A and D and B and C. B and C have the two of the same option. A and D has different option. What you realize, you can be cheeky here. You can literally just cancel A and D out. But let's confirm this stuff. We realize that decomposition of carbons. Remember, I told you the more reactive the metal. So the more reactive the metal, the more stable the carbonate is. Okay, the more stable carbonate, which actually means that it'll have to have you'll have to provide a very very high energy for it, very very high temperature for it to decompose that stuff. Okay, the more reactive, I'll give you guys the entire reasoning for that. And the metal that's less reactive, it will decompose the carbonate. So the less reactive metal, less reactive metal will have an unstable carbonate. So it'll want to decompose and become the metal again. Unstable carbonate. Yeah, so it decomposes easily. Something that's unstable, you can literally just decompose it very, very easily. So copper carbonate, copper was the unreactive metal, and copper is the unreactive metal, and it has copper carbonate right now. So you realize that the less reactive metal will have an unstable carbonate that can be decomposed easily. So A and D is wrong. Between B and C, I realized that calcium carbonate and potassium. Now, potassium is very, very reactive than calcium. You can see that through your reactivities. Please stop calling me a careless here. Potassium is more reactive than calcium. So it really means that potassium carbonate should be so stable that it couldn't be decomposed with a Bunsen burner. So between calcium and potassium, we realize, yes, calcium carbonate can be decomposed by a Bunsen burner, but it'll be decomposed with difficulty. But potassium carbonate, it cannot be decomposed at Bunsen temperature. So you have to provide even a higher temperature for that. Therefore, B is my answer, and we can eliminate Sereno. Okay. Okay, 27 says molten iron from blast furnace contains impurities. The process of turning and what are the reasons for blowing oxygen into calcium oxide? So you had calcium oxide, and it's saying what are the reasons for blowing oxygen? So you're blowing oxygen O2 and you're adding calcium oxide. The reason for that was obviously we needed oxygen in the first place to react with carbon. So carbon plus oxygen was giving me carbon dioxide. At first we had to remove that carbon. So literally C and D are wrong. We had to remove the carbon by reacting it with oxygen. And then why we were adding calcium oxide was to react with the silicon dioxide, that was our impurity to this, because this was a basic oxide and this was acidic and base acid. May we realized that we had a neutralization reaction taking place. So it reacts with the acidic impurities making slag, and then A was my answer because calcium oxide plus silicon dioxide was giving me calcium silicate. So calcium silicate, right? That was slag, and this could be used in making glass and stuff. Part 4 says, iron nails are added to 4 different metal sulfates. So in which solution does a displacement reaction occur? So a displacement reaction would only occur if iron is more reactive than that metal itself. So in which of these is iron more reactive? Magnesium is more reactive than iron. So iron can't displace magnesium in sulfate. It can't displace sodium. It can't displace zinc. So the only thing that it can displace is copper, because iron is more reactive than copper, right? Which statement about water is not correct? About pure water, it condenses at 100 degrees Celsius. Yes, sir, that's correct. It freezes at 0 degrees Celsius. That is correct. And then it says it turns cobalt 2 chloride paper blue. No, that's wrong. I'll tell you what. It turns anhydrous copper sulfate blue. Yes, it does. Copper sulfate is white. So that's why it's anhydrous. Anhydrous mean which does not have water. And once you add water to it, you realize that it becomes blue because the water of crystallization are being attached to it, right? So you realize that is happening. So it does do that, and C is therefore left. So C is my answer. Now about cobalt chloride is already blue. And once you add water to it, it turns it pink. So they try to confuse you with that. Cobalt chloride ka paper is already blue, guys. It's already blue in nature. It's not blue because of the water, okay? So it turns the blue cobalt chloride paper pink. If that was written, then we would say that is correct. Test for water, guys. So now part 30 says, Three processes in carbon cycle are shown. Methane reacts with oxygen producing carbon dioxide and water. Carbon dioxide and water are absorbed. Okay, so let's see कि इसको क्या कहते हैं. So methane reacts with oxygen. We realize when methane reacts with oxygen, carbon dioxide and water is formed, and this process is known as combustion. So we can literally say C and D are wrong. Then part 2 says carbon dioxide and water are absorbed by plants. So obviously, if they are being absorbed by plants, it's known as photosynthesis. Okay, so yes sir, it's known as, and oxygen is being released. I don't even have to see part 3 to say that A is my answer. Yes, so oxygen is used by living thing to release energy, and that is known as respiration. Okay, so in Haber process, nitrogen and hydrogen are reacted to make ammonia. The forward reaction is exothermic, and it says, okay, if this is exothermic, so forward is exo, the backward is endo, and it says what will happen if the temperature, what will happen, how do I get the maximum yield of ammonia, right? So I need maximum yield of ammonia. Okay, how do I get that? If I reduce my temperature, the exothermic will favor the exothermic part and more ammonia will be formed. So let's have a lower temperature. So C and A are wrong. I have to have a lower temperature. What about the pressure? So I realized that high pressure favors less number of moles, right? So if I increase the pressure, it will favor here of gas. So here there are 4 moles of gas, and here on the right hand side I have only 2 moles of gas. So if I increase the pressure, it will favor the lesser number moles of gas, that's ammonia, and more ammonia will be formed. So I need to have a high pressure, therefore B is my answer. D is also wrong. Okay, which process used to prevent iron from rusting involves sacrificial protection? Sacrificial protection was actually having a more reactive metal being attached, or more reactive metal attached to iron, right? To iron. And what you realize is in submissive वो कब होता है? In electroplating, those of you who is converting it in, confusing it with electroplating, you use a more reactive metal, maybe that's iron, and you coat it with a lesser reactive metal like copper or silver or gold. That's what electroplating is used for. Alloying, no sir. Galvanizing, yes, galvanizes is actually coating iron with zinc, and what you realize is zinc more reactive than iron or less reacting than iron? You realize that zinc is a more reactive metal than iron, and that is actually what sacrificial protection is, adding a more reactive metal to iron. So C is the right answer. Painting is just coating it with paint, right? So, and B is also wrong. So C is my right answer. Now, a student suggests 3 uses of calcium carbonate. Manufacture of cement, yes sir, it's used in, I've told you guys and I've explained it. Manufacture of iron, it's used there because calcium carbonate is decomposed because of the heat. Thermal decomposition happens to make calcium oxide plus carbon dioxide, and this calcium oxide then reacts with silicon dioxide to make calcium silicate. That's like treating alkaline salts, no sir, because calcium carbonate is a weak base. It is not used in treating alkaline soils because it's an alkaline. It's an alkali itself. So calcium carbonate itself is an alkali. Why would it treat alkaline soils? It should treat acidic soils. Yeah. So that's very stupid of Cambridge. I'm sorry, Cambridge. I don't mean any harm. So A is my answer. Okay. Then one of the reactions, sulfur dioxide plus oxygen sulfur trioxide, we know that vanadium pentoxide is used. So V2O5 is used. That we've done this so many times that C is mine. It says which catalyst is used to increase the rate of reaction. Obviously C, because it lowers the activation energy. Okay. What is the disadvantage of making ethanol from ethene rather than by fermentation? You realize fermentation means you're using glucose, which was a renewable source of energy. Ethene comes from crude oil, and it comes from alkane ki cracking, and you realize that crude oil is a non-renewable source of energy. Sorry guys. So what is the advantage? What is the disadvantage of making it from ethene? Because it's a non-renewable source of energy. And C, a non-renewable raw material is used. B is an answer. The product is very pure, should have been a disadvantage. The rate of reaction is very high, should have been a disadvantage, should have been an advantage. This should have been an advantage. This should have been an advantage. This should have been an advantage. So B is the only disadvantage. Okay. Which statement about compounds in the same homologous series are correct? They have same chemical properties? No, they have similar chemical property. Always, guys, eliminate these big extreme statement. So they have similar chemical properties because they have the same number of carbon. And no, they don't have the same number of carbon atoms. They have different. So methane is C1, ethane is C2, propane is C3. So yes, A is wrong. They have same physical properties. No, similar physical properties, right? So B is also wrong because they have the same number of carbon. No, they again have different number of carbon atoms. Okay. They have different chemical properties because they have different numbers of carbon atoms. No, that's now because of the different number of carbon atoms, they have different physical properties. And we've done this because since the carbon atoms increase, the state changes, and this happens and that happens. So it only affects the physical properties. The chemical properties are similar. They don't have different chemical properties. Then homologous series का फायदा क्या हुआ? So C is wrong. They have different physical properties because they have different number of carbon atoms. That's true. Because methane is more flammable, maybe decane is not so flammable, it's a solid, and methane is a gas. So you realize all that stuff. Okay. Increasing the number of atoms in one molecule of a hydrocarbon increases the energy when it is burned. Okay, what is the correct order? So which has the least number of carbon atom, the number of atoms in this molecule? So ethene has C double bond this, and hydrogen, 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 and methane is only one carbon with hydrogen. So obviously your less energy should be contained by methane because it has less number of atoms. It is, and it's given you as that increasing the number of atom increases the amount of energy released. So here you have less number of atoms, therefore it should have a lesser energy. Then does ethene have more atoms, or ethane have more atoms? So ethane is C bonded to this, and it has 6 hydrogens. So it's ethane is actually C2H6, and ethene is actually C2H4. Therefore you realize that ethane has more atoms, so it should give off higher, it should release more energy. So it should give more energy or release more energy. Therefore ethane should be the one releasing more energy, and therefore D is my answer. Okay, ethene should have lesser energy release. Now, an organic product P reacts with zinc to produce gas. Now, zinc is a metal, and P should only react with zinc if it was an acid, and the gas produced Q, that's obviously gonna be hydrogen gas, right? So metal plus any acid, and what you realize is that this will give you salt plus hydrogen gas. So what's my acid? You have ethanoic acid with you, and this should be hydrogen. The Q gas should be hydrogen. We've done all of this good stuff. You want me to do it? So zinc plus CH3COOH. Zinc displaces the hydrogen right here. So you get CH3COO, and this will be whole twice. This will be zinc plus the hydrogen gas, and you can then balance this stuff out. Okay. Alkanes undergo substitution reaction in the presence of UV light. Which equation represents a substitution reaction of ethane? So it's ethane is C2H6, and it'll have chlorine being there to it, and so one hydrogen will be replaced by one chlorine. So C2H5 Cl plus and HCl will be formed, right? So obviously C is wrong, D is wrong because hydrogens are being formed here, and A is wrong because 2 moles are formed. So B is the only correct option. If you see, it corresponds to my equation as well. The last equation, the last question, finally, it says which substance are natural polymers? Proteins are natural polymers. Carbohydrates are natural polymers because they are made up of glucose and they are starch. Okay. Nylon is synthetic. Polyethylene is addition, and it's also synthetic. So 1 and 2 is the right answer. Reno. So I guess we have all our correct answers now. You can check them out. I've done them in front of you, but I think all my answers are obviously correct. So let's mark ourselves 40 out of 40. Let's mark ourselves 40 out of 40. Okay. Let's do that good stuff. Let's go up and let's say 40 out of 40, and capiche. It was so easy. Capiche, so easy stuff. Butter. Yeah. All right, guys, see you in the